Hello everyone, my name is Marijin G. Hoyla, currently studying at Philippine Normal University Visayas, taking the majorship of Bachelor in Mathematics and Science Elementary Education. And I am thrilled to be your teacher for today. I am excited to embark on this learning journey with all of you. So together, we will explore universal law of physics, which is Galileo and Newton's inertia. And I am committed to supporting your growth and success. Here's our learning competency for today's lesson. Explain the subtle distinction between Newton's first law of motion or law of inertia and Galileo's assertion that force is not necessary to sustain horizontal motion. By now, you are very much knowledgeable about Aristotle and Galileo's ideas regarding motion. You have learned previously that Galileo was concerned with how things move rather than why they move. This is of course contrary to Aristotle's focus, which is more on the cause of motion. He showed that experiment, not logic, is the best test of knowledge. Galileo's finding about motion and a concept of inertia discredited Aristotle's theory of motion. Today, you will learn more about motion, particularly how Newton's built on Galileo's ideas and how the way was opened for Isaac Newton to synthesize a new vision of the universe. Let's go to our proper discussion. Galileo's horizontal motion. But first, let us know who is Galileo Galilei and what is motion. Galileo Galilei was an Italian physicist, mathematician, engineer, astronomer, and philosopher who played a major role in the scientific revolution during the Renaissance. What is motion? Motion is the movement of body or object. A common characteristic of all moving bodies is that they change their position with time. A body is said to be in motion or moving when its position changes continuously with respect to a stationary object taken as reference point. In an experiment in which he let a perfectly round ball roll down on an inclined surface, Galileo was able to observe the following. As the ball rolls down the inclined plane, it speeds up. As the ball rolls up the inclined plane, it slows down. On perfectly, completely horizontal plane, the ball neither speed up nor slow down. Galileo claimed that under ideal conditions, that in the absence of friction or air resistance, this means that no force will cause a change in motion. The ball would continue rolling up to a height above the base equal to the height from which it had been released. Galileo suggested that natural horizontal motion is the motion at a uniform speed in a straight line, and this is just as natural as at rest state of motion. Galileo developed the concept of inertia, which is the tendency of an object to maintain its initial state of motion, may it be at rest or in motion. Next, we have the Newton's law of inertia. Let us know first who is Isaac Newton. Isaac Newton is well known for his discoveries in optics, white light composition, and mathematics, which is calculus. It is his formulation of the three laws of motion, the basic principles of modern physics, for which he is most famous. His formulation of the laws of motion resulted in the law of universal gravitation. Next is, what is inertia? Inertia is the tendency of matter to resist changes in its velocity. Inertia looks slightly different from impetus. Inertia is an intrinsic property of matter. It is the property of matter which opposes changes in velocity. Newton's notable discovery was to show that the two different kinds of motion can be thought of as different aspects of the same thing. He introduced the idea of motion being affected by a force, then transformed the idea in a quantitative manner. Newton claimed that things tend to keep on doing what they are doing. The following are examples of Newton claim. You can impress your friends by pulling a tablecloth from under some glasswares. To be more successful, you can use a smooth, hemless cloth. When you pull the cloth quickly in a downward direction, the glassware will not be disturbed. It will remain at rest.
This demonstration of inertia can be a nice surprise for your guests at the dinner table. You need confidence and courage to do this demonstration without creating a big mess. For me, it's a challenge, so I usually scream to summon my courage. Ready? 3, 2, 1. We did it! You need to pull it fast enough for these plates not to have time to move. They're heavy, inertia. Having a silk, smooth cloth helps. It probably won't work for a large table, and please do not do it with your favorite plates.
You are standing still in a stationary bus, but suddenly the bus moves forward. Your body has inertia, and so a force is needed to change its velocity. The bus floor accelerates your feet, but your body falls backward. As you hold onto the handle, the force exerted by the bus through the handle gives your body a forward velocity. On the other hand, when the bus suddenly stops, your body will continue to be in motion, and so it moves forward until something stops it. Take a look at this video. Newton associated the concept of inertia to mass. Originally, he called mass as a quantity of matter, but later redefined it as a measure of inertia. This means that a more massive object has more inertia or has more resistance to change in motion than a less massive object. Newton's first law of motion, which is also known as the law of inertia, states that a body at rest remains at rest, and a body already is in motion remains in motion, with a constant velocity, constant speed, and direction, in the absence of an unbalanced applied force. With this, it can be said that although Galileo did not fully explain motion, he laid the foundation which eventually changed the view of the motions of objects. Galileo's revolutionary work profoundly influenced Sir Isaac Newton, the pioneer of the laws of motion. Galileo knew that external forces affect motion. This was expressed in his definition of natural horizontal motion. What Galileo failed to mention, which was explained by Newton, was that just as a force would cause acceleration in horizontal motion, the natural acceleration actually observed in vertical motion is the effect of the vertical force, the force of gravity on the body, without which the natural vertical motion would also be at a constant speed, just like natural horizontal motion. Hence, the idea Newton was pointing out was that the fundamental difference between Galileo's natural steady speed horizontal motion and the natural accelerated vertical motion is that vertically there is always the gravitational force acting, and in its absence, for instance, far into space, the natural motion that is with no forces acting in any direction would be at a steady speed in a straight line. The law of inertia presents a different way of viewing motion from the classical idea that continual forces were needed to maintain motion. We know now that objects continue to move by themselves to overcome the presence of friction. As well as to set objects in motion, initially, forces are needed. The object will move in a straight line indefinitely if it is moving in a force-free environment.